What we'll see is if the robot actually runs into me or into something, we're going to see a spike in current, and the robot's going to sense that and stop. So this allows us to put a robot in a place without a cage, which is very new and innovative. So now we've got a safe, force-sensing robot, and it's sensing it all through current. So this is what we call a collaborative robot. And what collaborative means is it's designed to work with people. So you can actually teach this robot by grabbing it and moving it. And when you look on the screen here, you'll actually see the robot moves in real time. So as we program, we've got a list of waypoints here that the robot will actually go through. So when you're doing a traditional robot program, if you think about it, we're just going to go from point A to point B to point C, maybe do an action. So this is where our gripper might open or close to pick something up or set something down. So what we've got are pieces inside called harmonic drives, and that's actually basically a gear that allows us to get extreme precision, so 30 micron repeatability with our robot. And we also have force sensing inside of the robot. What we'll see is if the robot actually runs into me or into something, we're going to see a spike in current, and the robot's going to sense that and stop. So we've got a protective stop that just happened. Again, the robot's trying to drive from one point to another. As the resistance goes up, the energy that it takes to go to that point goes up, and then we'll cut it off and say we've impacted something. So this allows us to put a robot in a place without a cage, which is very new and innovative. So now we've got a safe, force-sensing robot, and it's sensing it all through current.
That's interesting. I'd always assumed that force sensing just had some sort of movement sensors in here and it expected movement and it didn't get it. Yeah. It's literally just monitoring the current consumption?
Exactly. So let's go to the log here. So here's the actual current right here that we're seeing. So if I push on it, you can actually see the current spiking. So what we've done with Universal Robots is made programming extremely easy. And the benefit of that is you can deploy a system very, very quickly as opposed to taking maybe weeks or months or years. And maybe our company has changed before we've actually deployed it. So this is a very good robot for a company that's trying to grow quickly and needs to move very fast and stay flexible. So as you put a product into the field, you're going to have a lot of different customer experiences. And so when customers feedback information to the company, maybe I want this, maybe I want that, there's teams that have to decide, should we as a company actually add this feature? So that's something that I do get to be a part of, is talking to the marketplace, listening to the marketplace and saying, hey guys, everyone really wants this new thing, we've got to do it. And then when you actually see that new feature roll out, it feels really good to be a part of that. Yeah, so we run into new projects, new applications every day. I think that's the most exciting part about my job, is getting sucked into problem solving, talking to the smartest, sharpest people in the world, and you're helping people solve crazy projects, and that's fun to be a part of.